Hello, Marauders. I'm Thunder, the talking geometry dog, and I'm going to teach you some geometry today. All right.
All right, so we had some basic ideas like adjacent angles, some vocabulary, adjacent angles, angles next to each other. They might not be the same unless they're marked the same. Complementary angles, two angles that add to 90, like 70 plus 20 or 80 plus 10. They make a right angle. They make a corner. So a right angle is 90 degrees. Supplementary angles, two angles that add to 180 or a straight line. How do you remember which is which? Well, this is 180. 90 comes before 180. Well, C comes before S in the alphabet. And some people do this. Complementary. What if you just took this and went, whoop? Now it's like a 90. See, there you go. Or supplementary, some people just go like this. The S, supplementary, go like that. Ta-da! And go 180. So different tricks. Vertical angles. Angles, two straight lines and angles exactly opposite to each other. They're always equal. It's like a mirror image. They're called vertical angles. Can't be crooked. Transversal is a line that connects or crosses two parallel lines. So here's two parallel lines, and the transversal cuts across. Trans means to cross. That's pretty much it, the cross, okay? The transversal line. And the corresponding angles are angles in the same position, like these two orange angles. They're in the same spot. Or these two green angles are in the same spot. They're always identical. And since these two purple angles are the same, and since this purple angle is the same as this pencil angle, and this purple angle is the same as this pencil angle, I could even do the Z. Some people draw on the Z on here and go, wait a minute, I can go whoop, 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 like that, the Z. So if you can make a Z with parallel lines, then this angle must be the same as that. They're called alternate, because they're on alternate sides of the red transversal freeway. Interior angles. There's a right angle. So they're on alternate interior sides. Here could be alternate exterior. All right, so I'm going to go through the practice test. I'm going to go fast because you can pause whenever you want. Here it says, name some stuff. Vertical angles. Okay, angle 3. Where's angle 3? Here's 3. Who's he vertical to? This one, number 2. Alternate interior. Oh yeah, 4. Okay, here's 4. I guess I'll use another color. 4. This is the alternate interior is really the Z. So there you go. 4 and 5. They're the same. And alternate exterior. Here's 2. Exterior. This is on the exterior. This is the interior. Exterior is out here. Exterior, like the exit. The alternate sides, 2 and 7. They're the same. 2 and 7. And then what else we got? We got corresponding angles. Anybody in the same spot? Angle 1. Okay, who's in the same spot as 1? Who's right there? This guy right here. 5. In the exact same position. There's other ones, but the only one that goes with 1 is 5. 1 and blank are supplementary. Oh, wait, there's many answers. Supplementary means 180. Who's next to it? I could go like this. 1 and 2. Or I could have went this way. 1 and 3. So I could have picked either one. Question 2. How much is angle A? Let's see, how many angles are there? 1, 2, 3, 4. 4 angles. That's 360 degrees, whether it's a square or a rectangle. If you forget, remember you can always do this little trick. Go from one corner to the other. Look, I've got 2 triangles. Each triangle is 180. 180 and 180 is 360. So just use your calculator. Go 360 minus this, this, and this to get A, and A would be 50. Next drawing. How much is angle X? So say, oh, wait, these are the same. That means this and this are the same. If these are the same length, the angles are the same. Remember we talked about short sides and long sides? So this is also 61. And then I know it's a triangle, which is 180. So just subtract, boom, 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 from 180. Left over is 58 degrees. Next drawing. This is 115. What's A, B, and C? You know what? Just write them all in. 115. 115. Okay. And then, That means this is 115 and this is 115. All these ones in red are 115. Notice they're the big angles. They're obtuse. Well, here's the little guys. Whoop, 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 whoop. What are they? Well, if I just cover part of this up, and just go like that, there's a straight line. So just subtract that from 180. This leaves this little piece here. That's 65. And of course, I could fill all these in. The little guys is 65, and then fill in the 3 letters. And what would they be? We got 115, 115, and B is one of the little guys, 65. Okay, next drawing. Oh, what do we got here? It says A, B, and C. Don't think you have to do A first. That looks hard. Let's go right here. Let's see. This is 75. Well, oh, got a straight line. So why don't I fill in this one? This must be 105. What does that tell me? Wait a minute. We got some parallel lines. Parallels. 35. Wait, let's keep going. Don't turn here. Got to go to the other parallel line. Make the Z. Zorro strikes. 35. This is 35. In fact, I'll fill that in right now. Oh, wait, I already got C, 105, and I need B. Oh, wait, I got a triangle right here. Let's just fill in the triangle. Add up to 180. Every triangle is 180. So when I subtract, that leaves this last piece as 40. There it is. If I wanted to, I could do another Z. Z, Zorro strikes. This would have been 40. In fact, this is vertical, 105. Hey, here's another triangle. But see, these weren't the same. It's kind of reversed. Next drawing. Ooh, here's a funny one, but it is parallel. Find the Z. 20. Keep going, keep going, keep going. Boom. See, use the parallel. So this guy's 20. Here is 20. Do I need to know that? I don't know. Here's 110. Wait, if that's 20, 110 and 20, there's a triangle. Fill in the missing angle. That would be 50. What else we got? B. How am I going to get that? Well, many ways to do this. This is 110, so this is 110. Oh, let's finish this triangle. So 20, 110, 50. And then this is a straight line. So straight line, make this look like a 50. And a straight line, that would be 130. There's even a rule called the exterior angle rule that says an angle on the exterior of a triangle, that's outside, is the sum of the 2 angles on the inside. Okay, here's another one. And what do we got here? Oh, we got some vertical angles. What do we know? We know they're exactly the same. Oh, but somebody didn't tell me what they are. But they are equal to each other because this angle is the same as this angle. So do some algebra. X plus 30 is 4x minus 15. Solve it. Get x to one side. Subtract an x off, 3x. Add the 15, makes it 45. 3 times what is 45? X is, all right here. X is 15. Yay. Oh, what's angle A, B, C? We got to go back and figure that out. Where's A, B, C? Oh, here's A, B, C. A, B, C. Okay, this is 15. X is 15. 15 plus 30 is 45. How do you know you didn't mess up? Check it in the other one. You got time. Put it right there. This better be 45. Put a 15 right in there. 4 times 15 is 60. 60 minus 15 is 45. Woohoo! So since I know these both have to be 45, I checked it. It works. Next drawing. Let's see, what do we got here? Let's see, are these equal to each other? No, this looks bigger than that, but it's a straight line. There's your straight line, and straight lines are 180. Just like triangles are 180, straight lines are 180. So this plus this equals 180. So let's go 2x plus 10x, that's 12x. This looks familiar, doesn't it? Is 84 is 180. So this plus this is 180. Let's subtract the 84. 12x, 180 minus that's 96. I'll divide with my calculator. 12 times what is 96? That would be 8. How do you know you're right? Don't just stop. What is angle ABC? ABC. Remember, look for something that includes A, B, and C. And B is in the middle because it's in the middle of the angle. So this angle here, you know x is 8. Plug it in. 2 times 8 is 16 plus 84. 16, 84 is 100. How do you know you didn't mess up? It doesn't hurt to check the other guy. What if you put 8 over here? 10 times 8 is 80. I don't want that one. Oh yeah, but 100, this side is 100, and this side is 80, and that makes 180. Woo! So I know I did it right. Let's go to this one. What do we got? This is 22. Does it go here? Here? Wait, who's he vertical to? Where's his rope? Cover that part up. Maybe just cover that up. See it now? This guy's 22 degrees. Now I can go, let's see, wait, here's a straight line. Straight line is 180. But somebody cut it right in the half. These are exactly the same. See how they're marked the same? That means they go together. So this plus this plus this. Let's see, what's 180 minus 22? That leaves me 150, 58. Okay. This whole giant piece is 158, and somebody's chopped it right down the middle. So each one of these must be 79. So I can fill that in. A is 79, and B is 22. Next drawing. Ooh, this is a challenging one. I don't even know where to start. I see some parallel lines. I see some more parallel lines. Okay, let's go through this. Now, this problem may have given you some problem the other day because, this is that practice test if this looks familiar. But how did I start this? There's so many ways I could start this. This is 44. So I said, why don't I go right here and put a 44 there? I started there. What else did I do? This is 85. So I put 85 there. Now I could finish the triangle. 85, 44. This piece right here is 51. That's how I got that piece right there. Now what could I do? Well, this is 51. How do I know that? The Z. See, because he's parallel. And then once again, I was able to finish this triangle, 85, 51, and 44. Or I could do a reverse Z, or Z. And then from there, I started to just keep going. And what else could I do? So then I looked for something else. Okay, so from here I said, what can I do? I see here's 44. Wait, these are the same, aren't they? That means these guys opposite are the same. So I could fill a 44 in right there. So I got 44, 44. Let's finish up this triangle. So this down here, just subtracting from 180 is 92. Then what did I do? Well, I could bring the 44 over here. I could do that. And I could even fill this in. This guy, I could go straight. And they go, well, this would be 136. I don't know if I need that yet. And I thought, wait a minute, how about another Z? The Z. 44. 44, and I got E. And then where did I go from here? Okay, this one's hard to catch. These are parallel. How about this Z? And that's one way I could have done it. I could have did that. 44, I'll throw this guy in. So 44. 44. Hey, 44, 44. I could even do this Z right up here too. 44, 44. Subtract from 180. The missing piece in here is 92, 92. You know what? I don't know if I need that. I'm trying to get D, aren't I? So let's see, what do we got? We could go, here's 44 is vertical. Here's 51, 51. Now I can finish up that triangle. This guy here is 85. Yeah, so I could have also figured this angle out. I could have said 85 plus 95. I could have did that one. I could have did over here 92 and 88. Just whatever I needed. Down here, rectangle. To get to rectangle, I know it's got corners. It's got 90-degree corners. It's got right angles. What did I do here? 66. 66, right? I could go, okay, let's make this guy straight. He's a straight line. So 114, 114. But one thing I noticed about rectangles, which we didn't mention, this doesn't cut this in the middle. It would for a square, but not a rectangle. But isn't this symmetrical? Doesn't it have a mirror image? The diagonal lines in a rectangle are exactly the same length. That's how people actually determine if something's a rectangle. If you drew just something and say, hey, is your rectangle perfect? What people do, like if they're laying out like a football field, they measure it diagonally this way and this way. And if those are the same, they got it perfectly rectangular. If this is off, they can adjust it. So that tells me that these are the same, which tells me I have an isosceles triangle. So I did 180 minus 66. What was left was 114, and I split it into 2. Cutting that in half gives me 57s. And then from there, this is identical over here. And then now I was able to say, hey, this is a corner. 57 plus 33. This is a corner. And that's how I figured in the missing pieces, 33 and 57. And lastly, this hexagon, I go, how many angles? What do, wait, that's not a triangle, but wait a minute. Start with a corner. What do you got? 1, 2, 3, 4 triangles. Each triangle is 180. Just do it from one corner. 4 times 180 is 720 degrees. So, and since this is a regular hexagon, you know that it's identical all the way around. So let's cut that into 6, which makes every angle 120. 120, 120, 120, 120. And now I got a straight line. So this straight line, 120 and 60 and 60, 60, 60, and that actually makes this 60 to make 180. That's an equilateral triangle. So that's 60, and A was up here, was 120. And here's a little secret that's kind of neat. Of course, the more sides or angles, the bigger the angles. But if I did this, if I went like this, went straight all the way around, these are called exterior angles. 120, that's 60, 60, 60, 60, 60, 60. There's 6 of them. These are called exterior angles. 60, 60, 60 adds up to 360. And here's a little secret. The exterior angles always add to 360. And it doesn't matter, oops. Doesn't matter if it's a triangle, a square, a pentagon, an octagon, a decagon, a dodecagon. The exterior angles always make 360. The old trick. Okay, and if you're still watching, which you should be, this will help you in the test tomorrow. I want to make a picture frame that's hexagon shaped. Maybe it'll be a mirror. I can look at myself in the mirror. There I am. Whoa. Okay. If I were to make this out of wood, what angle should I cut these at? Let's zoom in a little bit. There's the edges. What angle do I cut those at? So what do I have to do to solve this problem? There's more than one way to do this. So what do you think? I'll pause the video and let you think about, where do I cut this? Where do I cut that? All right, welcome back. So what can I do? Let's see. Looking at this piece a little closer, I know this is a hexagon. And some of you remember from the last question that all the angles add up to 720. And since there's 1, 2, 3, 4, 5, 6 of them, each corner interior angle is 120. So if I look at this, this is 120, this is 120, all the way around. Now what do you know? These are parallel, aren't they? Those are parallel. So if that's parallel, what's this over here? Wait a minute. This is 120. So this, isn't this the same thing? Isn't that another hexagon? Isn't this also 120? Isn't this also 120? Somebody cut it right down the middle because you don't want crooked. So this is 60 and this is 60. This is 60 and this is 60. What about over here? Wait a minute. Can I do the Z? Not quite. But how am I going to describe this? What's left over right here? All the way around a circle is 360. So 360 take off 120 leaves you with 240. This is 240 degrees. Cut down the middle, 240 cut in 2 is 120. And here's something. Remember, this is parallel. Isn't parallel like a straight line? And what is a straight line? 180. Same with this. This is 120 because that's a straight line. So it could be over there. I could imaginary extend that and make this 120. What do all 4 of these add up to? 180, 180, 180 plus 180. 360. Oh yeah, everything with four sides is 360. It all makes sense. I use geometry all the time. It's one of the fields of math that I use constantly in real life because I see things and they're all have shapes. So there you go. Tomorrow, Friday, is the test. Be prepared. You can use all your notes. Hopefully you'll do well. It should be a lot of fun, and maybe this will appear again. See you tomorrow.